Good evening. My name is Wahid Lutfi. I'm going to show you some of the Python interpreter and Python modules. So let's get started. With that in mind, I'm going to first show you the interface, which is https colab.research.google.com. As you can see that I'm on the notebook or notebook of Jupyter notebook of CoLab and research.google.com. So if I just basically print this URL, which is inside Python interpreter, the notebook, I'm going to just get this URL. And if I click on this URL, basically it will open up the Google Research CoLab page, which is a notebook, a Jupyter kind of notebook, and it has the entire interface. Since I already opened one, I'm just showing you that this is really cool stuff that Google provides. You can just learn it for school, for work related, and then just, it's all free unless you want to just use some real professional kind of computation nodes in there. So just let me cancel this one. I'm going to close this window. I'm going to come back to this one. So, and I'm going to remove this one. And this is going to be just as it was on the first one. I'm going to be discussing the math module today. The math modules of Python inside the Python interpreter. So as I mentioned before, we're inside the Python interpreter using Jupyter Notebook. And how do I know that one? If I just say import sys, and then just import that module, then I say dir of sys, you can see on the sys, there's a lot of kind of flags and exceptions and double underscore method and methods that are already defined constants. So you could get those constant, for example, sys.executable, to see that what version of Python I'm using, sys.executable. I need to not do a dir anymore. I need to do a print on it. So when you do a print on it, it will just say you have a user bin Python 3 there. And then if I just want to go for the release and major information, I could say version info. That would also tell me that the major version, the minor number, and everything else. So we're running 3.7.15. And you can also get that information by just typing in system.version. So we get that information with the GNU C collection compiler 7.5 version, and that was compiled with it. So this one is all good. Now I want to just do import math module. So let's do import math. If I just import math and then do a dir on dir of math, notice that when you do this, basically you're getting like a bigger list here with all the modules and methods and constants that are used here. And then if you want to get help on it, for example, you could say get the help on this one. That would just tell you that every function, every constant that are used, for example, math.py and math.e, the sine function, the cosine function, the square root function, everything that is available here, you will see on the output, all this one and the list of them. So in addition, you can also get, for example, do a print, the type of the print on the type of this math module. So you can also get this as like it's a class module. So let's just do some stuff with the math module now. For example, if we get print on the help of a specific math module, like math.logarithm of base 2, which is binary, then you can see that this is going to tell you, you can run the log2, which takes a number x and then returns the logarithm of that x on base 2. Base 2 meaning binary. Binary, what I mean is that you can just do, again, print help on the bin for binary. So the bin is going to return a data type of whatever number you provide. It gives you the equivalent binary number for it. So for example, if I just say, go ahead, let me comment these two lines out, and then I don't want to get help on them. We know the syntax already. So you can always get inside the interpreter help and then the IDE help. And then some of them, for example, it does require, like if I say print bin, and then I say, let's say 32, 32 would be in binary would be this number, 0 and then 1 and then followed by all those digits, right? So if I just get the binary equivalent of that number, but now let's do say print math.pow of 2 to the power of 5. 2 to the power of 5 is 32. So when we do this one, it does print out 32 and a number. So how do I know this one? That I can just do something like this. If I just say math dot, let's get another line here. And then on this line, I'm going to say print math dot logarithm of 2. And then I'm going to just get from 32. So the logarithm of the 32, because 2 to the power of 5 is 32. So this one should get a math dot. I need to put the dot. The idea is putting this squeaky characters under it, saying that you have a typo. Now I corrected the typo. I should have the value. So now you can see that a power of 2 to the power of 5 is 32, and logarithm of that number is 32 also. So if I want to say print math.pow for power and 2 to the power of 8, for example, that would reveal 1024. I'm sorry, 256 in number. The 10 is 1024. So let's get the 10. I'm going to demo that one. 1024 is which is 1K. And then if I just do that one, then I could say print math of log of 2 of 1024. I should get back the 10 here. You can see that it is 10. So log of 2 base logarithm of a number base 2 is giving me the binary equivalent of that number. So if I want 64, that would be 8, I believe, or 6 actually. 6 to the power of 6 is 64. To the power of 5 was 32, so the next number is 64. 128 would be 7, 256 would be 8. So if I do a 256, that would be 8. And you can see it's a 8 here, that number. So we know this logarithm. Let's try logarithm of base 10. So if we just look at this help statement here, and then we want to just do the same statement, but this time we're going to go logarithm of base 10. Base 10 meaning that the number is to the power of 10 to the power of that number. So logarithm, it says the base 10 logarithm of x is going to be returned. So what does that mean? That if I just say, let me comment that line out, and then I'm going to say print math.log of 2, log of 10 base 100. So 10 to the power of 2 is 100. So this should give me 2. And you can see it is giving me 2. The binary number that we printed out, we could just do a number of ways. You can print out binaries, hexadecimal, octal numbers, and so on. But I'll just come back to those ones on another video. At this time, I wanted to show you logarithm of this one, so that's why I show you the bin. But X and octal and ordinal and char, all of those ones are different way to, we could talk about the octet numbers and Unicode and all those ones on another video. At this time, I'm going to just cover some of the math modules directories here. So we did this one. If I do 1,000, 10 to the power of 3 is 1,000. So I should get 3 here. And then I do 3. And similarly, if I get to 4, that's that 10 to the power of 4. And then 1 million would be just 10 to the power of 6. So 6 digit. And similarly, 1 billion would be a little bit more. So I just 9. And then the trillion, million, billion would be like to 12, and peta would be 15, and so on. Exa would be 18, and let's say at this time we're discussing logarithm, and we just found out those numbers are coming. But I want to just also show you something like this. So let's say if I say import math as M, that's a short form, then I could say print and then type of M. That is the same thing as we had to say class module. So it is class module because the math module. So it is an alias that's pointing to the math module as that. At this time, if I do a dir of M, everything with the dir of M also is showing what I had with the package math module. So if I just say here again, one more line, say import math, and then just run another print statement here, print dir of math, these two lines are going to print out the equivalent lines. That's why I have 2 of them on a row on the same thing. But I don't like this horizontal information that is forever going there. So let me show you a trick on Python, how you could just write a Python script to format them in a nicer way for yourself. So you can just get it into maybe 5 columns or something. So let's just write that one. Since we wrote the math already as M, I'm going to just put this line here, which is, I already wrote it. And so you could just see it is faster to rewrite it. But notice that it is there. And let me explain what this is. Earlier, when we did the math module, if I just say dir of M, this one is going to just give me one long line on the top. If I print it, print that one, it's going to give me a longer line. But then I need to just maybe somehow have some line separator here, print, and then I'm going to just say new line character. Just one new line character is good enough. So it will just print this, and then oh, that's long, right? So now if I just rerun it, the code is going to produce the same output, but notice that this is too long to read it. Here I have it more under control, which means I can go there and then read the entire column this way. Yes, I have here that is under control too. But if I just comment this one out, it is more pleasant for the eyes if you just have it in one column in front of you if the list is small. So like, for example, here, I don't need these 2 lines anymore. I'm not going to display all of them at all the time. So you can see that these 2 lines are there. And I don't need the space here. And then these other 1 lines are good. So what I'm doing here, as you can see, I'm importing the math module for first as M. Then I'm just saying print out column-wise format, which is this information here. And then I'm breaking into a line number. If it is five of these attribute or double underscore method or any method or constant, then I want to break him after the 5 line with a new line character. So I declare this variable called n is equal 0, and then I go through the same dir of m with each item, and then as I print the item, I for item, then I just go inline terminator at the end of that one. But then I just say increment the number. So once it reaches n module 5 is remainder is 0, then I will print a new line. So notice that if I just change this one to 10 of them, obviously, and the columns are gonna get bigger, and then the number of lines in this screen is going to get smaller. So that I just thought that maybe 2 is small. I don't want to do that, and it's gonna go on more screens. So 5 is a good number, because even if I just do this one, if I just want to save this one as a short, that I could just put them into one screen so you can see it better on the videos. At this time, we did discuss this information, but let's just do another technique of just getting rid of all of this. And then this time I'm going to just look for a particular string. So if I just look for a string of function cosine or sine or pi or anything, I could just say that this statement, let's just run this one, and you can see it is just listing every function that I was looking at. So if I just say, for example, here, if something, a string called log n and the item printed, now I get the other functions, logarithm of log 10, log 1 pi, log 2. So then I could say, well, also f this one or another string called pi, for example, math.py or something. I could get those ones, but notice that the list is so much because a lot of them have that word. But if I just say, rather than pi, show me radians, then you could see that it is there with or radians n and this. So why is this one still giving me a larger number? I need to just see one or more of these ones or matching this. So yeah, radians is this one, and log, because I was having the usage of or statement. So this one, it is matching both of those things, only it is there. So at the same time, both of them cannot be true. So I'm going to just say or, either this or that. So let's just see if the or is actually matching everything here. So let's just go here with radians, and I will show you what are the things you can do with radians, for example. So if I just say here, and instead of this for statement, I could just say print help on m.radians, and then I could get the help on that function, or radian takes the x and then convert angle of x from degrees to radians. So from 90 degrees to radians. And what do I do with that one? Let's just do this, and we could just say print, and we're going to say math dot cosine of math, math dot actually not math dot, since I used the m, I'm gonna say m dot radians, and then at this time I'm going to just call it the radians of 0, but I need to do return the cosine of it, math dot cosine or m dot cosine of it, and then that would be perfect for this one, except that I have to add one more field here. So now you notice that cosine of 0 degree is going to be returning 1. And then if I just do the same thing for 180 degree, that's also going to be 0, or actually -1. 90 would be 0, I believe. And 90 would be 1 cosine of 90 degree. It's actually a different number. So m dot cosine, let me just say radians. I'm going to try this number. You just write the brackets and the formulas a little bit off. It will just do this. So math dot cosine of this, I'm going to just say this, and I don't need this. So I already use the math function module, and then math dot cosine. So cosine of math dot radius of 0 is that, and then I get the 360 of that one. Let's see what. Yeah, the 360 is 1, and then 180 degree cosine is -1, which is accurate. So all of that one, and then 90, I believe, is 0. No, for some reason 0 cosine, and then sine 0, and then 90 would be 1. Sine of that one might be the case. I forgot some of those numbers. Yeah, sine of it is 1. So you just have to look at those ones, and then a lot of those ones are formulas that you can easily remember, because the Cartesian product, 1, 0, 1 is cosine, and 0 is sine for the first one, and then 0, 1, and so on. It's on the 90 degree is 0, 1, 0 being cosine, and 1 is sine, and that's why I get that 90 degree. Similarly, for the 180 degree, it is this one, 180 degree would be cosine would be -1, I believe. Cosine would be -1, and then sine of that one is 0. It should be 0. My sine of 180. Let's see what it is. Sine is a different number. Oh, sine hyperbola. No, I don't want the hyperbola. And 1.22. And then let's see, -180. I believe I'm looking for -180 in this case. Yeah, that's -120. Okay, so let's just get these other things covered. So I'm going to do import. So let's say print math.py pi value. When you get the pi value is 3.14 something, right? A large number, 3.14, and then the rest of the numbers. So that is in floating point number, and it's the precision is important that you have to cover it. Normally we write 3.14 in short form for 2 point precision. So let's get to another examples of here. When you're looking for sine and cosine, we already did that one actually. Let me just see what else I have here. So at this time, I think I'm going to end this video, because I covered a number of things. But I could just, before I end it, let me just do a dir of math, see what other things could be interesting for you that I could cover. Sine, cosine, and tangent, hyperbolic, format, gamma. A lot of these ones, infinity, and then is infinity, it's not a number, and so on. All of those ones we can cover. The one thing that I want to cover here is POW function, and then a square root. Let me just do those two. So so if you do a help on the POW function itself, and this is a Python POW function. See that Python POW function, it has 3 arguments, X, Y, Z, and then where help of math.pow, this one has 2 arguments, and then you can see X and Y is that it takes a value of X and to the power of y. Whatever value you want to the power of that one, it will do it. But then this one also has a remainder value with 3 arguments. So you can just also get the return of the remainder of them. So that's how you could get the remainder value here. So if I just say, for example, print math.pow of 2 to the power of 5, let's do the to the power of 10, which is 1. I mean, 2 to the power of 5 is 32. We could just do that one easily. Let's just do that one, and we get 32 here. So this one, now we are going to do the same thing, print pow of 2 to the power of 5. And then we don't give a remainder. If you don't give a remainder, it still is going to return 32. But notice this one is, and the first one is a math is returning in floating point, and the second one is a real number and not the floating point integer value. So let's see if we just do a type on both of them, the type of one versus the other one. And we just run the 2 type. One is says class float, the other one says class integer. So I'm going to just not show this help anymore because we're done with it. And then we could just use one more parameter of this one for to the power of 5. So when we are using this without the math module, I say that it takes an argument. By default, it is not none, which means you don't provide it. But to the power of 32 is 5. And then if I just do equivalent of this one, let's say 2, just a remainder of that 2, it's going to just say, okay, I need to remove the type anymore from these. I don't need to get the type. So I don't need this bracket. I don't need this bracket. I don't need this, and I don't need this. Having extra bracket is not going to hurt, but it's not necessary. So 32, and then the remainder is 0. But if I just change that one to a 5, and the remainder is not going to be, so 6 times 5 is 30, and then the remainder is 2. If I just change this one to a 4, 8 times 4 is 28. Sorry. Yeah, 8 times 4 is 32 automatically, so it is getting it there. Let's do a 3. That's a different number. Now remainder is this. So 10 times, no, not 10 times. Yeah, 10 times 3 is 30, and then the 2 is remainder. I just, on my mind, translated everything that I learned math as a kid in Afghanistan in Farsi language. So I had to translate it in Farsi and then come up back to English. That's why I said the numbers. So sometimes our minds are like working, but we just have to do it the way that we learn it. Okay, so this is some other example. And I also mentioned that I'm going to show you the square root. So print math.square root function. This one is going to just return the square root of a number. So a square root of 100, for example, is 10. So if I just do math, print math square root of that one, and then you can see that it is a square root of 100, not 3, and not 10. And that's a 100. And then 1000, let's say 81 is 9, and you can see 9 times 9 is 81. And then, so then you can also do this kind of representation, print, and then you could say, for example, 9 times 9. That would just be like a number multiply this one. Again, this is not the same as 9 to the power of it. This is not power of 9 to the power of 9. It is not, okay? So this is 9, and this is actually a 9 to the power of 2. So those are equivalent. And then let's see power of this one. I just add an extra bracket here. I just parentheses, and then I'm going to close it. And then now you see it is getting power of 9 to the power of 2 is 81. And if you want to get the square root of that one, this is almost like a nested function calls, similar to a programming language called Lisp. It's object-oriented programming. So object-oriented programming concept is that you could say the module name, method name, and then here we're just using a function that's inside Python, not the math module. But if I want to use the math module, this would also work, and then just get the same number. Okay. I hope you enjoyed this session, and please don't forget to like and subscribe at our channel, YouTube at MyWebUniversity. And this is basically a handle, my YouTube, and I'm right here. You can see that I have more than 400 or 500 videos. So you're welcome to like them and subscribe them. And this one is for the World Cup. Please don't forget to join and watch the World Cup. It's really fun. Unfortunately, some of the teams that are very strong, they're not winning anymore. Maybe they should get to understand the game, that when they have the opportunity to score, they should not miss it. And if they miss like out of the 9 key or 10 key strikes that they have, they don't score 2-3 goals, then that's what's going to happen. 2-1 or 1-2. Like Argentina should have not lost that game. But unfortunately, they scored 3 goals that they were offside. By the first goal, when they were offside, second one, they should have figured it out. And then whenever you're in that level of professionality, it should come, the mindset of the players should be that we have to correct it inside the field. We cannot just come out of the field and regret it later, that I should have done this or should have done. This is what the difference between like people are amateur versus professional. Professional has to make it 90% of the time to the level that they practice and work for it, and to have the same outcome. Germany lost to Japan today 2-1 similarly, but I noticed that Spain had a great game, and then they are very young players. So most likely these young players are gonna stay on the Spain team for a long time. They played against a little bit weaker team, although Costa Rica is not a weak team by general. One time I remember, and they lost to Brazil on the first time of the season, similarly, like 6 goals, but this time today to Germany, 7 goals. And unfortunately, they don't have the maybe the kind of like level that this World Cup that they played today. So they were not ready. And then I remember when there were a time that Costa Rica was actually had a great goalie. They went to penalty kicks and all the way to almost to quarter. And they passed quarterfinal and to semifinal, and that was all the goalies. They were 0-0, and then or whatever was the score, and then the penalty they were winning, and because they had a great goalie. Goalies are very important. Defenders are very important. Midfielders and forward. But you don't want to have one loophole on a team that you're playing. Every team has to have every spot covered. Even the sub players should be ready 100% just to substitute. Even if they play 10 minutes or 20 minutes or half of the game, disregard to how much they play, when they come up, the level should not be any different from the level that was already playing. And in fact, sometimes the fresh legs should improve it better. All they have is the technique and tactique that they play together. Tomorrow, I think Portugal, Cristiano Ronaldo is playing against Ghana, and I believe Portugal is going to win that game. I just guessing there. And there's Brazil also playing. Brazil is gonna most likely win also. I think for now, so far, the games that I have seen, both Spain and Brazil. I have not seen Brazil yet, but because Neymar is also there, and then they have some good teams all the time. And the chance for a lot of the teams are kind of like an option. We will see how Argentina does the next two games, and it's very important for Argentina to just set the stage at the next two game and win both of them. Otherwise, they will be out. Spain, the year that won the World Cup, had a similarly situation. They lost against Switzerland on the first game, and then they had to play against. They had to play against Chile, I think, and they had to win one more game before Chile. When they played against Chile, I think that was David Vela. I think David. I think I forgot his name. It was David something. David Vela or David Vias or something. And he was a good forward for Barcelona, and he scored two goals against Chile. One of them was from outside of almost close to the 40 yards on the corner on the side, that he just saw the goalie had come out, and the goalie was open, like empty goal. So he kicked it from like by the line, really, for 40 yards shot, and then scored. And then the third one that they needed the most was that he scored on that game, and that one and that game hit the post once on the right side, then it went to the left side post and hit the left side post, and then it went in. Now, imagine that how lucky you get on a game, that you're scoring two goals, and with all much the talent that he had, he dominated that game, and then that's how they continued on in the shining on the World Cup that season. But prior to the World Cup, they won it at that time that Iniesta scored against Netherlands at the last minute. Prior to that one, they had already were performing really good at the European League, and then also on Barcelona. They had such a strong players on that team, and unfortunately, some of them, they got older. They didn't come back, and then when they played against Netherlands, just the following cup, they got lost 5-1 or something, and they were just dominated by Netherlands team at that time. And then Netherlands didn't win that World Cup, but Spain got disqualified. Unfortunately for Italy, in the past two World Cup, they have been getting eliminated. They are not even getting qualified. So they need to rethink about their players, to see that why we had such a great star players, and all of a sudden we cannot produce anymore. There's something that needs to be done. All the people that they aged out, Italy has not worked out on their team, and they're not getting qualified anymore. And this is the second World Cup that they got eliminated and were not qualified. Let's just stop in there. I'm going to show you some more of these videos. And these are all Python videos and shell script and Unix script and operating system like Windows, Linux, and other modules. And then I have some shorts. Some of my shorts are basically for the purpose of you can see the longer videos, the full videos, because a lot of people, when they see an hour video or half an hour video, they don't even click on it, and so they don't even watch the content of it, how good it is. But I'm making these shorts so they can understand the objective of the longer videos, so they can get started learning it them as they go. So that is all I have for today. I hope you all enjoyed it and have a great time. Take care. God bless you all.